Hello everyone, for this tutorial video I'd like to show how vectors work, which are arrow diagrams that are used to represent a number that is both a direction and a quantity or magnitude. Many vectors are not perfectly horizontal or perfectly vertical, but rather have a slant to them. So we can see, if we draw an imaginary line along the vertical part of the slant and an imaginary part along the horizontal part of the slant, we would form a right triangle as a result. And so, we can analyze the slant in terms of the horizontal and vertical components, using trigonometry. In particular, we can notice by the Pythagorean theorem, the magnitude or length of the vector must be the horizontal component squared plus the vertical component squared, and the direction of the vector must be the angle relative to the horizontal point. So we would use the inverse tangent function, although pay attention to the caveat mentioned in the last video. So adding 180 when necessary. For example, when the vector is pointed southwest or southeast. Although we did not figure out formulas for the x and y components of a right triangle with relation to the hypotenuse in the previous video, we can do that now in this video. In particular, if we pay attention to the fact that the sine of the angle equals opposite over hypotenuse, or in this case, the y component over the length of the vector, we can rearrange this equation and see that the y component must be the length of the vector times the sine of the angle, once we multiply the definition of the sine of the angle by the hypotenuse, in order to isolate the y component. By the exact same logic and proof, we can figure out the x component of a right triangle by multiplying the cosine of the angle by the length of the vector. As we notice, the cosine of the angle is the adjacent leg or the x component divided by the hypotenuse. Although figuring out the lengths of the individual components seems very useless at first, it can be used, for example, to estimate the horizontal or vertical distance of something like you or another physical object traveling along a slanted path rather than a straight left or right or up and down direction. And it is also often used in the study of physics to represent how powerful a force is, which is important in the study of something like mechanical engineering. Now that I have explained basic right triangles and their application in vectors, I can move on to figuring out angles of more sophisticated triangles, such as isosceles or scalene ones, as well as derive or prove special formulas that will work for any triangle, such as the law of sines or the law of cosines. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.